An estimated 55% of the total water used in the Okanagan Valley is used for agriculture. And water availability in the late summers, when water reservoirs are low and agricultural, non-agricultural, and other ecosystem demands are high, is of great concern. Climate change predictions suggest that these concerns over freshwater availability are only going to get worse. Now, what if farmers could reduce their water use during these times of short supply and high demand? Cherry growers may be a great candidate to do just that. Studies have found that reducing irrigation after the fruit have been picked in the late summers has minimal impact on fruit quality and yield in the following seasons. With approximately 3,500 acres of cherries being grown in the Okanagan Valley, and orchards expanding north and into higher elevations than ever seen before, reducing their water use could make a significant difference. But how much can we reduce their irrigation by, and how will this impact cherry trees being grown in the Okanagan Valley? This is the focus of my research. I'm investigating whether we can reduce irrigation after the fruit have been picked without negatively impacting cherry tree growth, phenology, or their ability to withstand winter temperatures. To do this, I've applied a post-harvest irrigation deficit of 25 and 50% in 5 different Okanagan cherry orchards that range in elevation and latitude. I'm focusing in on how this deficit impacts cold hardiness, or rather, the plant's ability to tolerate freezing temperatures, as this is a relationship that has never been studied before. You see, cherry fruit buds must survive the winter in order to produce the following year's crop, since they develop the season before they grow into cherries. If these deficits reduce fruit bud moisture, I predict it may actually allow them to withstand colder temperatures, which is important as climate change predicts greater weather extremes. To measure cold hardiness, I collect fruit buds from the fall to the spring, and I place them in a freezer that slowly cools them and records the temperature they freeze at, letting me know when they would die outside. This cold hardiness data will also be used to refine a cold hardiness predictive model. Growers will be able to use this model to help make decisions regarding costly frost protection techniques, such as using wind turbines or helicopters to help prevent frost damage. Through my research, I want to provide cherry growers with enough information to make informed decisions on irrigation and frost protection management so they can continue to meet the demands of cherry production while conserving water in the Okanagan Valley. Thank you.